Okay, in the last class we saw how to deal with systems of two linear equations, and we either saw that we could use elimination or we could use substitution to solve those. Now, when we're dealing with systems of three equations or more, I recommend using elimination exclusively. We will never do any examples of anything more than 3 by 3 systems. By that I mean we have three equations and 3 variables. And so when we have 3 equations and 3 variables, the idea is that you want to add 2 of the equations together and eliminate one of the variables, and then add another 2 of the equations together and eliminate that same variable, and then you're down to a system of 2 equations with 2 variables that you can solve, just like we did last class. So what I'm going to do is I'm going to label these equations A, B, and C. Okay? And now what I want to do is figure out a way to add A and B to eliminate one of the variables. And if I add just A plus B, you'll see that I get x minus y plus 3z equals 8. When I add that to 3x plus y minus 2z equals negative 2, then I get to eliminate the y's. Okay, so I just took A plus B and I eliminated y, and I should get 4x plus z equals 6. And I'm going to label that equation, I'll call that D. Okay? So now I want to add either A and C or B and C and get rid of the y as well. And so I think what I'm going to do is I'm going to take 4 times A and add that to C, because that will allow me to eliminate the y again. So 4 times A would be 4x minus 4y plus 12z equals 32. 4 times 8 is 32. And then I have 2x plus 4y plus z equals 0. And so when I add those together, I should get 6x plus 13z equals 32. Okay, and I'm going to call that equation E. And now what we want to do is write down the system D comma E, because now we have a system of 2 variables and 2 equations and 2 variables. So now we have a system D and E of 2 variables and 2 equations. Okay, so again, D was 4x plus z equals 6, and E was 6x plus 13z equals 32. And now to cancel one of those variables, I guess I'm going to take, I'll take 13d plus E. So I'm just going to set that right here, but then to actually do the cancellation, I'm going to take 13d plus E. So 13 times 4 is 52. Oh, and it should be negative 13d, right? Because I want a negative sign there. So this is negative 52x minus 13z, and then negative 13 times 6 is negative 78. Okay, and I'm going to add that to E, which is 6x plus 13z equals 32. And when I do that, I should get negative 46x equals negative 46. Notice that the negative 13z and the positive 13z canceled. And so I get x equals 1 is the first coordinate of my solution. Okay, well now we want to solve for y and z, and since we have these two equations right here, I can just plug in x equals 1 into one of those and solve for z. So let me do that now. So 4 times 1 plus z has to equal 6. So z has to equal 2. Alright, so now I have two of the variables, or two of the coordinates, and now I'm going to plug x equals 1 and z equals 2 into one of the other equations. So, do that. Oops. Let me do that here. I'm going to plug x equals 1 and z equals 2 into, let's say, equation A, which was x minus y plus 3z equals 8. So that becomes 1 minus y plus 3 times 2 equals 8. So that is 6 plus 1 is 7. So I got negative y plus 7 equals 8. So y equals negative 1. Okay, so now I have all three of my coordinates. So my solution is going to be 1, negative 1, 2. Okay, let's do another example. Here we have three equations, which I'll label A, B, and C again. So there's A, there's B, and there's C. Now you notice that B does not have an x. So I'm already down to two variables. If I can just get rid of an x in A and C. So what I'm going to do is I'm going to take A minus 2C, and that will allow me to get rid of the x variable there. So I have 2x plus y plus z equals 11, and negative 2x plus 10y equals negative 4. So when I add those together, I get 11y plus z is equal to positive 7. I'll call that equation equation D. And so now we're already down to a system of two equations with two variables. Write that down, so we are already down to two variables. And that's if we use equations B and D. So B is 4y plus 3z equals negative 8, and D was 11y plus z equals 7. So this is my new system of just two equations and two variables. Now we'll solve that the way that we did in the last class. Now I'm going to eliminate z. Oops. I'm going to eliminate z by taking b minus 3d. So b minus 3d will give me, let's see, I have 4y plus 3z equals negative 8. And let's see, negative 33y minus 3z equals negative 21. And so when I add these together, I should get, let's see, negative 29y equals negative 29. So y should equal 1. So I've found my y coordinate. Now I should plug back in. I should spell eliminate right. Eliminate z. Okay, so we just did that. And so now we've gotten y. And now I'll just take equation B and I'll plug y equals 1 into equation B, which is 4y plus 3z equals negative 8. So that's going to be 4 times 1 plus 3 times z equals 8. So then 3z is equal to 4. So z is equal to 4/3. Did I do something wrong? I did. Oh man. Common mistake there. I should actually write out what I'm doing. Right here I should have subtracted, wait, oh, it's a negative 8, that was my mistake there. So I gotta remember to actually write the equation down right. This is 4 times y plus 3z equals negative 8, so that means I should get 3z equals negative 12, so z is equal to negative 4. Okay, so now I've solved for 2 of my coordinates, or 2 of my variables, and now I need to plug in z equals negative 4 and y equals 1 into one of those equations. So let's do plug into c. So if I do x minus 5 times 1 equals 2, I can solve for x. So x should be equal to 7. Okay, so now I know my solution is 7, 1, negative 4. Alright, now on this next page we're going to look at some real-world examples of these systems of linear equations, which show up actually quite a bit. Okay, so it says a total of 400 people attend a community performance. The admission prices were $8 for adults, $6.50 for students, and $6 for senior citizens. Okay, the ticket sales totaled $29.17. At the theater's next board meeting, the manager proposed that for the next play they raise prices to $9 for adults, $7 for students, and $6.50 for senior citizens. He said that if the exact same number of people attend the next performance, the ticket sales would be 3,238. How many adults, students, and senior citizens attended the play? Okay, so there are a couple of equations we need to write down. So the first is, well, let's do this. Let's say what our variables are. So let's let x be the number of adults that attended the concert, or the show. Let's do y is the number of students, and z will be the number of senior citizens. Okay, so those are our variables. Now it says here that 400 people attended the show, so that would be if you took x plus y plus z, that equals 400, because that's the total number of people showing up, which is the sum of the adults, the students, and your senior citizens. So that's the attendance equation, we'll call that A. And then B is how much money we made, and so that would be 8, if you charge 8 for each adult, and $6.50 for each student, and $6 for each senior citizen, then they made $29.17. Okay? And the equation C is what would happen after if we change the price, and that would be 9x plus 7y plus 650z is equal to 3238. Okay, so there's a system of 3 equations with 3 unknowns, and we can go ahead and solve that. Okay, now in order to solve this system, what I'm going to do is I'm going to take 8 times A minus B. That'll cancel out the x's. So it's eliminating an x here. So now you have 8x plus 8y plus 8z equals 8 times 400, which would be 3,200. And then you have negative 8x minus 6.5y minus 6z, because I'm distributing in the negative sign there for negative b. That'd be minus 29.17. And so that will give me 1.5y plus 2z equals 283. And I'll call that equation D. And then I want to eliminate x from A and C, so I'm going to eliminate x again. This time I'm going to take 9a minus c. So now I have 9x plus 9y plus 9z equals 3600. And I'm subtracting off 9x minus 7y minus 6.5z equals negative 3,238. So that will give me 2y plus 2.5z equals 362. And I'll call that equation E. Okay, so now I have a system of two equations with two unknowns, and that's D and E. So let me just write this new system down. So that is, let's see, 1.5y plus 2z equals 283, and 2y plus 2.5z equals 362. And now I think I'm going to try and eliminate y. So I'll bring this over here. I'm going to eliminate y. And to do that, I'll take, let's take negative 4 times d plus 3 times e. That will give me 6y in both equations. So I have negative 6y minus 8z equals negative 1132. And then I'll also have 6y plus 7.5z equals 1086. Okay, when I add those together, I get negative 0.5 or negative 1/2 z equals negative 46. So that when I multiply both sides by negative 2, I get z equals 96 or 92. Okay. So z is equal to 92, and I can take that and plug that back into D. So then I get 1.5 plus 2 times 92 equals 283. So what is that, 184? Oops. So this is 1.5y equals, or plus 184 equals 283. So what does that tell me? That tells me 1.5y is equal to 99. So y must be equal to 66 actually. So y is 66. So now I have z is 92, y is 66, and I can plug those values back into equation A. So I have x plus 66 plus 92 equals 400. This is plug y equals 66 and z equals 92 into A. And when I do that, I get that x is equal to 242. So now my solution to this system is that there must have been 242 adults, 66 students, and 92 senior citizens. Okay, so that's the typical word problem involving a 3x3 system. We're going to look at one more, and this one I think I'll just set up and then we can look at it in class how to actually solve it. It says here that Florida Fruits packs 3 types of gift boxes containing oranges, grapefruits and tangerines. Box A contains 12 oranges, 5 grapefruit, and 3 tangerines. Box B contains 10 oranges, 6 grapefruit, and 4 tangerines. Box C contains 5 oranges, 8 grapefruit, and 5 tangerines. The shipping manager has 91 oranges, 63 grapefruit, and 40 tangerines. How many gift boxes of each type can she prepare? Okay, so now in writing this down again, we want to identify what our variables are. Those are the things we're solving for. So you might be tempted to say oranges, grapefruits, and tangerines are our variables. But that's not what we're asked to solve for. We're asked to find how many different gift boxes there are. So our variables are going to be like A, B, and C. So let me do this. Little a is the number of gift boxes of type A. And then little b can be the number of type B gift boxes. So type B, and little c will be the number of type C's. Okay, so those are our variables. And now we got to go back and read the sentences again and try and figure out how to turn those into equations. So the first equation says box A contains 12 oranges, 5 grapefruit, and 3 tangerines. Okay, so now let's see here. We have 91 oranges, and we have 63 grapefruit, and 40 tangerines. And now what we want to do is we want to write an equation for each one of these fruits based on how many go into each box. So if let's see here. So if you have the number of gift boxes of type A, so I want to say how many oranges go in type A gift boxes. Well, I guess box A contains 12 oranges. So for every box of type A, we have to use 12 oranges. Every box of type B, we have to use 10. And for every box of type C, we use 5. So I think it's 12A plus 10B plus 5C equals 91, because I have to use up 91 oranges. Now for grapefruit, let's see, it goes 5, 6, and 8. So I think it's 5A plus 6B, 6B plus 8C equals 63. Because we use 5 grapefruit in box A, 6 in box B, and 8 in box C. And then the final equation is on tangerines. Let's see, so that's 3A plus 4B plus 5C. Okay, has to equal 40. So here's a system of equations in our 3 variables, A, B, and C. And now we want to solve for A, B, and C. And we can do this using the elimination method. I think what I would do is I would eliminate, maybe I'll eliminate variable C. Yeah, why not? So what I'll do is I'll take, and maybe I'll call these equations O for orange, G for grapefruit, and T for tangerine. I think I'm going to take O minus T, and that'll cancel the C variables. This is eliminating C. So this is 12A plus 10B plus 5C equals 91 minus 3A minus 4B minus 5C equals negative 40. So then I get 9A plus 6B is equal to 51. So that'll be my new equation. We'll call that x maybe. Okay, and next we want to eliminate c again using one of the other equations. Okay, so we found x, and now I need to eliminate c again. So this time, I think what I'm going to do is I'm going to take 5g plus 8t, or minus 8t. And that will allow me to calculate or cancel the c's again. So 5g would be 25a plus 30b plus 40c equals 315. And then negative 8t will be negative 24a minus 32b minus 40c equals negative 320. So that simplifies down to a minus 2b, there are no more c's, minus 5. Okay, I'll call this equation y. And so now I have this new system of two equations, two unknowns. X is 9a plus 6b equals 51. Y is a minus 2b equals negative 5. Okay, and so now to eliminate b, I'll take x plus 3y. So this is to eliminate b. So I take x plus 3y, so that's what? 9a plus 6b equals 51. And then 3a minus 6b equals negative 15. So that's what? 12a equals 36. So then a is going to be equal to 3. Now if I take that and plug it back into y, that'll give me b. So let's see here. So now I plug a equals 3 into equation y. So you get a minus 2b equals negative 5. Well, a is 3. So 3 minus 2b equals negative 5. If I subtract 3 from both sides, I get negative 2b equals negative 8. So b is equal to 4. So now I have a and b, and I'll plug that into t to give me c. So plug a equals 3 and b equals 4 into equation t. So it's 3 times 3 plus 4 times 4 plus 5c is equal to 40. So that's 9 plus 16 plus 5c equals 40. So 25 plus 5c equals 40. So that's 5c equals 15. I'm just subtracting 25 from both sides. So c is equal to 3. So the solution then is 3, 4, and 3. We can make 3 gift baskets of type A, 4 of type B, and 3 of type C.